All right, let's jump right in. Imagine if you could give any AI an expert's memory, like in an instant. A kind of plug-and-play brain for any specialized field you can think of. Well, we're going to dig into a new technology today that might just make that a reality. Let's get into it.
So what's the big problem we're even trying to solve here? Well, large language models, they're incredible generalists. They can write you a poem, they can summarize an article, they can even spit out some code. But when you need a real specialist, a doctor, a lawyer, a financial analyst, that's where they start to fall apart. And turning that jack of all trades into a reliable master of one, that's one of the biggest challenges in AI today. And that really brings us to our first section here, the AI specialization problem. How do you take an AI that knows a little bit about everything and actually turn it into a master of one specific, super complex field?
Yeah, the core issue is really this. General knowledge just doesn't cut it for these high-stakes jobs. I mean, you wouldn't want a doctor who just has a general idea of medicine, right? No way. You need deep, you need reliable, and you need nuanced expertise. That's the gap we've got to bridge if AI is going to be truly useful in these fields.
Okay, so how have people tried to solve this up until now? Well, there are two main approaches, but as we're about to see, both of them come with some pretty big, pretty gnarly problems. You can kind of think of them as the flawed heroes of our story.
So up till now, you've had two main paths, and each one forces you into a major trade-off. The first one, DAPT, is like retraining the AI from the ground up on a specialized library. It's powerful for sure, but the upfront cost is just gigantic. The other method, RAG, gives the AI an external database to search. Cheaper to set up, but it's slow. Every single time. You're forced to pick a massive one-time cost or a slow, painful experience forever. Let's dig into DAPT for a second. The computational cost is just enormous because you're essentially retraining the whole thing. But the real hidden danger? It's something called catastrophic forgetting. By focusing so hard on all this new, specialized info, the model's brain can literally overwrite its old general knowledge. It becomes an expert in one thing by forgetting how to do everything else.
And what about RAG? Well, its biggest weakness is speed. I mean, it's got to search a massive external database for every single question you ask it. The process is painfully slow. We're talking about data stores that are 500 gigabytes or even bigger. That kind of delay just doesn't work in the real world. And what's worse, sometimes relying on this external cheat sheet can actually mess with the AI's own ability to think through a problem.
But this is where our story gets really, really exciting. What if you didn't have to choose between these two imperfect options? This is where a brilliant new solution, the memory decoder, steps onto the scene.
So what even is this thing? Okay, a memory decoder is a small, separate AI component. During training, it studies a massive database, what the experts call a non-parametric retriever, and it learns to predict exactly what information that database would pull up for any given question. So it's not using the database later, it's internalized the skill of perfect information retrieval. The process is it's so elegantly simple. First, you pre-train the small memory decoder. Think of this like forcing it to create the ultimate set of Cliff's Notes for a specific subject by studying this huge knowledge base. Then, and this is the cool part, you just plug this hyper-efficient memory into any compatible AI. That's it. The AI instantly gets expert knowledge without the slowdown of searching some external library. And this is the real magic of the memory decoder. It's a true plug-and-play solution. You can train one memory module for, say, biomedicine, and then attach it to a whole family of different AI models. They all get an instant knowledge upgrade without you changing a single line of their original code. It's just incredibly efficient and so versatile.
Okay, I know what you're thinking. It sounds great in theory, but does it actually work? Well, let's look at the data. The researchers put the memory decoder through a whole series of tough tests to see how it really stacks up against the old ways.
So the first key number here is perplexity, which is basically just a fancy word for how confused the AI is. A lower number means it's more accurate, more confident. And the results, they're pretty stunning. A standard model with a small memory decoder plugged in scored a 12.25. That is actually better than the same model that went through a full, super expensive retraining, which only got to 12.78. The tiny plugin beat the total overhaul.
So what does this staggering number mean? 140 times? It means efficiency. Researchers found that a small model with a memory decoder could actually outperform a base model that was 140 times larger. That's like a go-kart outperforming a freight train. It's insane. You get this elite, expert-level performance without needing a supercomputer to run it.
But what about speed? All that knowledge is useless if it slows the model to a crawl. Well, compared to the traditional retrieval methods, which can more than double the processing time, the memory decoder adds almost no overhead at all. It gives you expert knowledge without that painful hack, which makes it practical enough for the real world.
So, how does it do this? Well, part of the answer is that it learns to memorize like a database. So in this example here, the base model barely even considered the correct name Jacobi, giving it a tiny probability of just 0.12%. But the memory decoder, having already internalized that knowledge, confidently assigned it a 68.94% probability. It's recalling these obscure facts with just incredible accuracy.
But, and this is the other side of the coin, it's not just a fact machine. It also keeps the base model's common sense and reasoning abilities intact. While pure retrieval systems can get tripped up by simple language, the memory decoder correctly predicts common sense words like on and see with high confidence. It really is the best of both worlds, the memory of a database and the reasoning of a language model.
So, what does all of this mean for the future? This isn't just a small improvement. Memory Decoder is pointing toward a completely new, much more modular way of building AI.
This tech fundamentally decouples knowledge from the AI's core brain. So imagine, instead of one giant do-it-all model, you have a powerful base AI and a whole library of specialized memory modules. Need a legal expert? Plug in the law memory. A financial analyst? Swap in the finance memory. This makes building expert AI modular, super efficient, and dramatically cheaper.
And this is really why it matters. For businesses, for researchers, for developers, this approach just shatters major barriers. It means creating a powerful, specialized AI no longer requires a monster budget and months of retraining. It could become something you assemble in a fraction of the time and cost, which could democratize access to expert-level AI for everyone.
Which, of course, leaves us with a really fascinating question for the future. If we can create these plug-and-play memories for any specialized domain, what new capabilities are we going to unlock? Imagine an AI that can instantly become an expert geologist, or a master chef, or a historian of ancient Rome. The possibilities are truly wide open.